Good morning friends. Today we shall continue with our previous sessions. We have seen till now three cross sections and their shape factors. One was rectangular cross section, second was circular cross section. These two were symmetric cross sections. Third was the unsymmetric cross section, which was triangular cross section. Now in civil engineering buildings we come across different type of cross sections and shapes of cross sections apart from rectangle, square and triangle. Those are I-sections, T-sections, channel sections and so on. Okay, so today we shall deal with shape factor for symmetric I-section. I have drawn here an I-section with these particular dimensions. Width of flange is 100 mm, depth of flange is 10 mm and overall depth of the section is 250 mm. Width of wave is 6 mm. Now since the section is symmetric, we know that elastic neutral axis coincides with plastic neutral axis. So we shall start with our procedure for finding out shape factor. As usual, ZP is equal to S is equal to ZP upon ZE. So we shall first of all find ZE, which is nothing but I upon Y max. If you see, overall depth is 250 mm. So our Y max will be exactly at half of the depth, which is nothing but 125 mm. So our Y max value is 125 mm. Okay. Now we have to find moment of inertia for this section. So we will have to use parallel axis theorem. What is parallel axis theorem? BD cube by 12 plus AH square. So our section we will divide in different parts. These two flanges and one wave. So for this top flange, BD cube by 12 is width 100 into depth 10, so 100 into 10 cube upon 12 plus AH square, so 100 into 10, so this is A into, now what is H? H is distance between neutral axis and CG of flange or this particular area. CG of flange is at 5 from top and neutral axis is at 125 from top. So this distance we want. How much is this distance? 125 minus 5. Okay, so this is H square. So BD cube by 12 plus AH square for top flange plus, now we will come to wave part of the section. Width of wave is 6, depth of wave is 230. So 6 into 230 cube upon 12, BD cube by 12. A square will be 0 for wave because H will be 0. Plus bottom flange is same as that of top flange. So we will repeat this parameter, first parameter or first term of the equation. So 100 into 10 cube upon 12 plus 100 into 10 into 125 minus 5 square. Now we shall calculate this I value. So we shall now calculate this I value. 100 into 10 cube upon 12. Okay. 100 into 10 cube upon 12 plus 100 into 10 into 125 minus 5 square plus 6 into 230 cube, not square, 230 cube upon 12 plus 100 into 10 cube upon 12 plus last term 100 into 10 into 120 square. So the value is 34.89 into 10 raised to 6. 34.89 into 10 raised to 6 millimeter raised to 4. So now we can find ZE as I upon Y max. What is I? 34.89 into 10 raised to 6 divided by 125. So what we will get is ZE. So this is 279.14 into 10 raised to 3 millimeter cube. 279.14 into 10 raised to 3 millimeter cube. Now we need ZP. How to find ZP? ZP is equal to A1Y1, which is here. Then we will divide this I section into 4 parts. One is here A1, another is from this level up to neutral axis, A2, then A3, and then bottom flange is A4. So A1 is this flange, A2 is this part of the wave, A3 is this part of the wave, and this is A4. Okay, so our ZP is equal to A1 Y1 plus A2 Y2 plus A3 Y3 plus A4 Y4. So it is equal to, now how much is A1? A1 is 100 into 10. This is A1 into Y1. What is Y1? Y1 is difference of distance. Which distance is? Centroidal distance of area 1 and plastic neutral axis. So how much is this difference? 125 minus 5. So this is 120 plus A2. What is A2? 6 into, how much is this depth? It has to be half of 230, which is 115. So 6 into 115 into centroidal distance of A2 and neutral axis. This difference we have to find. So how much is that? So the part of the wave above the plastic neutral axis and below the bottom of this top flange, this part we want. So this is area 6 into 115 into, now difference of centroidal distance between of this area and neutral axis. We want this one. Correct? How much is this distance? This will be total 125. So this is A2 into Y2. We are finding Y2. So 125. From this you subtract 10 divided by 2. So this is A2 into Y2. Now we can make this 2 times. This whole thing we can make 2 times. Why? Because A1 is equal to A4 and A2 is equal to A3. Okay. So whatever is A1 plus A1 Y1 plus A2 Y2, same will be A3 Y3 plus A4 Y4. So we have made it double. Now we shall find it. ZP 100 into 10 into 120 plus 6 into 115 into 125 minus 10 is 115 upon 2 into this total is 2. So value is, so this value is 2 times. So we shall find out this value and it comes out to be 319.35 into 10 raised to 3 millimeter cube. Okay, so shape factor here will be ZP upon ZE. See what is ZP? 319.35 into 10 raised to 3 divided by 279.14 into 10 raised to 3. Take this ratio. So this comes to be 1.144. So shape factor for symmetric I-section of this size is 1.144. Now we shall see shape factor for a T beam or T crossing. 4. Thank you. Now we shall solve or find the shape factor for T section. Here are the cross-sectional dimensions of the T section. Flange size 120 width and 10 mm is the thickness, and web 10 mm thickness and height is 120 minus 10, so 110. So again with the basics, shape factor is equal to ZP upon ZE. Finding out ZE is using this formula as usual, I upon Y max. Finding out I is a little bit involves calculations because we need to locate first of all location of neutral axis. So we shall assume our reference line is top, and with respect to top we shall find out what is the location of neutral axis. So y top, okay, y top is equal to, again there are two areas, A1 and this is A2. So A1y1 plus A2y2 upon A1 plus A2. This we already know, so we need not do or I am not going to write anything here in details. I directly write the values, so hopefully you will understand. So 120 into 10 A1y1 plus A1, this is A1, into what is y1? Y1 is centroidal distance of area 1 from top. So how much is centroidal distance from top? 5. So this is A1 y1. Now second area is 110. Carefully see, 120 minus 10 is 110 into 10. So this is A2. Now what is Y2? Find out what is half of 110. Half of 110 is 55. Okay. So 55 and this you add 10. So what is Y2? Centroidal distance of area 2 from top. So this is 55 plus 10. Okay. 65. So this is A1 Y1 plus A2 Y2. Totally divided by A1 plus A2. What is A1? 120 into 10 plus A2 110 into 10. So now we shall calculate this value quickly. 120 into 10 into 5 plus 110 into 10 into 65 upon 120 into 10 plus 110 into 10. So value is 33.70 mm from top. Okay. So now we will get or find I value. What is I? BD cube by 12 plus AH square. Again parallel axis theorem. So BD cube by 12 for flange 120 into 10 cube upon 12. BD cube by 12 plus AH square. So 120. So AH square 120 into 10 into H. Now what is H? H is distance between neutral axis and centroid of area. So what is the distance? CG of A1 is 5 from top. Neutral axis is at 33.75 from top. 33.7. So you will find out this difference. 33.7 minus 5. Okay. So this distance we want. This is H. So 33.7 minus 5 square. This is first area. Second area 10 width into depth is 110. Correct? Depth is 110. So BD cube by 12 plus AH square. A 10 into 110 into what is H? Centroid of this second area is at 65 from top. Correct? We have already shown here 65 from top. So 65 minus, you subtract 33.7 square. Okay, so this is I value for T section. Now we will calculate this quickly. So 120 into 10 cube upon 12 plus 120 into 10 into 33.7 minus 5 is 28.7 square plus 10 into 110 cube upon 12 plus 10 into 110 into 65 minus 33.7 square. Okay, so this is 3.185 into 10 raised to 6 mm raised to 4. So what will be ZE? I upon Y max. Now what is Y max? Y max is either Y from top or Y from bottom. Total depth is 120. Correct? Total depth is 120. Y from top is 33.7. So Y from bottom is 120 minus 33.7. 120 minus 33.7 is 86.3. Okay. So while substituting Y max, we need to take care of this in case of unsymmetric sections, because Y is not half of overall depth. So which one is more? Y bottom. So I value 3.185 into 10 raised to 6 divided by 86.3, that is equal to, let us calculate, that is 36.906 into 10 raised to 3 millimeter cube. Okay, so this is ZE. Only 50% portion we have covered. So that is why I earlier said finding out shape factor for an unsymmetric section is lengthy jaw. Now we will go for ZP. Finding out ZP is also easy. Now, while finding out ZP, again we need to locate plastic neutral axis, like we have located elastic neutral axis. Okay, so as per the assumption, area above the plastic neutral axis is equal to area below the plastic neutral axis. Now how much is the total area? 120 into 10, okay, and 110 into 10. In this, flange area is 120 into 10. It means in flange zone more area is there, more than 50%. How? This is 120 into 10, this is 110 into 10. If this becomes 120, then both will be equal, but this is somewhat smaller. It means flange area is slightly more. It means probably plastic neutral axis may lie in the flange zone. So you assume that, what you have to assume? Assume plastic neutral axis in flange. Okay, assume plastic neutral axis in flange. So there will be definitely some depth out of 10, okay, lesser than 10, and whole width. That total area will be above the plastic neutral axis. So for time being, we shall assume that the depth of plastic neutral axis from top is YP. Okay, somewhere here. So this depth is YP. So this total area, that is shaded area now. I am doing it so that you will understand. So this shaded region is above the plastic neutral axis. Okay. So YP into 120 is equal to whole of the area below the neutral axis. Now how much is the area below the neutral axis? This is 110 into 10, and this small depth of 10 minus YP and 120 width. But instead of that, we will make one more simple trick. We know both areas are equal. Area above the plastic neutral axis, area below the plastic neutral axis. So we know how much is total area, A1 plus A2, correct? So we will make half of this area. We will make half of this area, which is nothing but area below the plastic neutral axis. Simple. So half into 120 into 10 plus 110 into 10. Okay. From this we will get YP, that is depth of plastic neutral axis. Very simple. So 120 into 10 plus 110 into 10 upon 2 times 120. How much is the area? Depth 9.58 mm. 9.58 mm. So our assumption that neutral axis is within the flange is correct. Okay. Now how much is the area above the neutral axis? A1 we shall say now. Okay. A1 is equal to 9.58 depth into 120. What is this product? Calculate. 1149.6 mm square. Okay, 1149.6 mm square. What is Y1? Y1 is nothing but YP, 9.58 mm. Now there are two parts below the plastic neutral axis. One is this smaller part. How much this? How much is this? We shall call this as A2 just for simplicity, or this is area in compression zone. Okay, correct, above the plastic neutral axis. Now we shall find out what is area below or area in tension zone. So there are two areas. One is this small strip A2. So A2 is 9.58 minus 10 minus 9.58 into 120. How much? It is 50.4 mm square. And how much is Y2? Y2 is centroidal distance of this shaded region from plastic neutral axis. Okay, so there is one small correction, 9.58 upon 2. Y1 is centroidal distance of A1 from plastic neutral axis. So 9.58 upon 2 is 4.79. And Y2 is centroidal distance of small strip from this plastic neutral axis. So 10 minus 9.58 upon 2. How much is this? 0.21 mm. Okay. And A3, there is one more area which is below the tension zone or in the tension zone, below plastic neutral axis. So A3 is this, where 10 into 110. How much? 10 into 110, 1100. And Y3, what is Y3? Distance of, centroidal distance of this area from plastic neutral axis. So this total is 110. So 110 by 2 plus 10 minus 9.58. So 55 plus 10 minus 9.58. So 55.42. So our ZP is nothing but A1Y1 plus A2Y2 plus A3Y3. We have got all the values. So A1 is 1149.6 into Y1 4.79 plus A2Y2 is 50.4 into 0.21 plus A3 1100 into Y3 is 55.42. So total area, total addition is 66.48 into 10 raised to 3 mm cube. Okay, over. So only this part is little bit new compared to previous questions or analysis. So shape factor ZP upon ZE 66.48 into 10 raised to 3 divided by 36.906 into 10 raised to 3. Calculate this value. So 1.801 So shape factor for this particular T section is 1.801. I hope you have understood this. If you are new to this channel, please subscribe and hit the bell icon and like the video. If you have any queries, you do ask in the comment section, and I also request you to refer my previous videos if you have any difficulties on what is the concept of shape factor, and also see the video for introduction to plastic analysis. Thank you.